Assuming zero initial condition, the response y of t of the system is given below. For the unit step response is, we have to choose the correct one. So here for this system, the input is a step function and impulse response is also is 1 by s. We need to calculate what is y of s. So for such type of system, the equation, output equation in time domain, y of t is equal to input x of t convolved with h of t. Impulse response is h of t. So when we make convolution, we will get the output. So we take Laplace transform on both sides. Y of s equal to Laplace of x and Laplace of h. So x input Laplace is, input is, they set as input is a step function, that is 1 by s, whose Laplace is 1 by s. Impulse response is also given as 1 by s. So when we multiply 1 by s square, again when we take inverse Laplace transform, so 1 over s square, whose inverse Laplace is t into u of t. T into u of t, that is a linear function or ramp function. So y of t is equal to t into u of t. So this is the correct answer. Assuming zero initial condition, the response y of t of the system is given below. For the unit step response is, we have to choose the correct one. So here for this system, the input is a step function and impulse response is also is 1 by s. We need to calculate what is y of s. So for such type of system, the equation, output equation in time domain, y of t is equal to input x of t convolved with h of t. Impulse response is h of t. So when we make convolution, we will get the output. So we take Laplace transform on both sides. Y of s equal to Laplace of x and Laplace of h. So x input Laplace is, input is, they set as input is a step function, that is 1 by s, whose Laplace is 1 by s. Impulse response is also given as 1 by s. So when we multiply 1 by s square, again when we take inverse Laplace transform, so 1 over s square, whose inverse Laplace is t into u of t. T into u of t, that is a linear function or ramp function. So y of t is equal to t into u of t. So this is the correct answer. So the next question is, impulse response of a system is h of t is equal to t into u of t. For the input of u of t minus 1, what will be the output? So here this is system, impulse response h of t, input is x of t, output is y of t. The relation among these three is y of t is equal to x of t convolved with h of t. When we take Laplace transform, y of s is equal to x of s, h of s. So given x of t is given as u of t minus 1, so it is a delayed version of a step function by a delay amount of 1. So how much it is delayed by 1? So that means when we take Laplace transform into a step function, Laplace is 1 by s, it is delayed by 1. So e power minus 1 into s. So it is delayed by 1. So e power minus 1 into s. Again it is given h of t impulse response is t into u of t. So h of it is a ramp function. For ramp function, impulse Laplace transform is 1 by s square. So x of s is e power minus s into 1 by s. H of s is 1 by s square. So when we combine, y of s equal to e power minus s by s cube. Again, Laplace transform of any square function, t square is equal to 2 by s cube. This is we know Laplace transform of any square function is equal to 2 by s square. So here for this function, multiply and divide by 2, it is 1 over s cube. 2 over s cube. We can replace when we take a inverse Laplace transform, we can replace as t square. So 2 over s cube. For this function, we can take as t square. But e power minus s meaning that it is delayed by an amount of 1. So that means this t square is delayed by an amount of 1, that is t minus 1 whole square. This time is delayed by an amount of 1. So for this entire thing we can write as t minus 1 whole square. Of course we have the 2 in the denominator, and it is available only, it is starting from at 1. So this is answer, t minus 1 whole square divided by 2, this answer. The Laplace transform of f of t is equal to 2 square root of t upon pi is e power minus 3 by 2. What will be the Laplace transform of g of t? This function is. So the given function is f of t is equal to t 2 into square root of t divided by pi. That we can write like this. So for this function, you once you differentiate, that is 2 over square root of pi is constant. So square root of t, we know the well-known formula d by dx of square root of x is 1 divided by 2 into square root of x. So when we differentiate this root 2, we have 1 by 2 root t. So when we combine and simplify, 2 cancel, and combine, we can simplify, we got the answer square root of 1 divided by pi into t. So that is nothing but g of t. Therefore g of t is differentiation of f of t. G of t is the differentiation of f of t. So when we take Laplace transform, g of t becomes g of s. So differentiation of any function whose Laplace is s into f of s minus initial condition. So that initial conditions we are not taking. So s into f of s. So what is f of s? F of s is the Laplace transform of f of t, which is given as e power minus 3 by 2. So which is f of s is Laplace transform of f of t, which is given as s power minus 3 by 2. So when we simplify, we got the answer as s power minus 1 by 2. So g of s is the Laplace transform of g of t, whose value is s power minus 1 by 2. So s power minus 1 by 2. This is the answer. Next, consider a signal is defined by x of t is like this. It's what will be the Fourier transform of the given signal x of t is this. So here x of t is defined e power j 10 t, which is lies between plus or minus 1. So the function is existing from minus 1 to plus 1. So we need to calculate what is the Fourier transform of this function. So as we know, the formula for Fourier transform is Fourier transform of any function is equal to integral minus infinity to plus infinity x of t e power minus j omega t dt. So the given function is e power j 10 t e power minus j. So combining here this limit is reduces to minus 1 to plus 1, since the function is existing only over this period. So minus 1 to plus 1 e power, combining these two terms and integrate this, then substituting upper and lower limit, and bring it to standard form. So this is in the sin theta formula. For this we can reduce into sin of, sin theta formula is e power j theta minus e power j2 theta divided by 2j. So we can write, for this we can write sin of omega minus 10. So the answer is 2 divided by omega minus 10 sin of omega minus 10. So this is the answer from the given answer. This is the answer. So Fourier transform of signum function. The signum function is represented like when time greater than 0, the function value is 1. For time less than 0, the function value is minus 1. So positive time, the function value is 1. For negative time, the function value is minus 1. So this signum function can be realized using two functions called, the first one is a step function whose magnitude is 2, it is a step function, and a negative DC signal whose magnitude is minus 1. So when we add these two signals, that is step function magnitude is 2 and a negative DC signal, when we add, here we have 2 minus 1, we have the plus 1, and 0 minus 1, 0 plus minus 1, we have the minus 1. So this is nothing but a signum function. That is, signum function can be realized two times step signal minus 1. Now we will take this signum function as x, whose Fourier transform is x of f is equal to Fourier transform of signum function. This signum function we are writing x of t is equal to 2 times u of t minus 1. So differentiate on both sides. So we have dx by dt. Here 2 into differentiate this and differentiate this constant. So this constant differentiation of a step signal, differentiation of step signal is nothing but a impulse signal. So it is as it is. Now we have the property called the differentiation property in Fourier transform. If x of t whose Fourier transform is x of f, if that signal is differentiate with respect to time, whose Fourier transform is just to multiply by a factor of j2 pi f. So here we have the differentiation of x of t when we take a Fourier transform j2 pi f into x of f. According to this property, differentiation of any signal is j2 pi f into original x of s. j2 pi f into original x of f. So again, this Fourier transform of impulse signal is 1. Fourier transform of impulse signal is 1. So therefore x of f keeping left side, remaining term to other side, it is 2 upon j2 pi f, again x of f is equal to 1 divided by j pi f. So this x of f is nothing but Fourier transform of signum function. So therefore Fourier transform signum function is equal to 1 divided by j pi f. So let f of x be the real and periodic function which satisfies f of minus x is equal to minus f of x. In the general form of Fourier series, representation would be, so here and this given as f of minus x is equal to minus f of x, meaning that this is a odd function. So we know the definition for odd function, x of t is equal to minus x of minus t, or otherwise x of minus t is equal to minus x of t. So it is a odd function. So the odd function, meaning that in the Fourier series only odd function is present and the even function is absent. So we know that sine function is a odd function. So that function alone present in the Fourier series expansion. The cosine function is absent. So this is not the case, and this is not the case. Again, here it is somewhat different in 2k plus 1, and here the coefficient is corresponding to cosine function. So this is not the case. So the only case is f of x is equal to sum of k is equal to 1 to infinity. This is the case. So this is the answer. Suppose the maximum frequency of any band limited signal x of t is 5 kHz. What will be the maximum frequency of that x of t is getting multiplied with cos of 2000 pi t in kilohertz? So question is any signal having maximum frequency is 5 kilohertz. That signal is getting multiplied by cosine signal. What will be the maximum frequency in kilohertz? So here f of t, let we take as this f of t is x of t is getting multiplied cosine of cos 2000 pi t. So before proceeding this, we will recall what is frequency shifting theorem, frequency shifting property of Fourier transform. So here any signal x of t whose Fourier transform is x of f, that signal is getting shifted in frequency domain by f naught. When the corresponding time domain changes is just multiply by e power j 2 pi f naught t. That means any signal x of t is getting multiplied by e power j. The result of this function having the Fourier transform of just replace f by f minus f naught. So again back. So here x of t cos to 2000 pi t. Now for this cos function you write Euler's formula. Now again just getting multiply inside. Right. Now we will take a Fourier transform both sides. We will take both sides Fourier transform. This left side we have f of t whose Fourier transform is f of omega. Now x of t getting multiplied by e power j 2 pi f t. So here x of t e power j 2 pi f t whose Fourier transform is x of f minus f naught. So here x of f minus. So here what is f naught is, so it is in the standard formula 2000 pi, that can be 2 pi into 1000. So here we have 2 pi into f naught. So 2 pi into f naught value is 1000. So f naught value is 1000. And for similarly for this function the Fourier transform is capital X f plus 1000. So this 1000 we are writing 1 kilohertz. This is 1 kilohertz. So in the given problem the maximum frequency in x is 5 kilohertz. Now after multiplying with the cosine signal, now the frequency is increased by 1 kilohertz. So the result is 5 plus 1 6. So it is a maximum frequency 6 kilohertz. Similarly in the negative side also we have the reduction in the frequency, that is 5 minus 1. Maximum frequency given as 5 kilohertz. Now it is 1 kilohertz is getting subtracted. So the minimum frequency is 4. Minimum frequency 4 kilohertz and the maximum frequency is 6 kilohertz. A signal represented by x of t is equal to 1 for the time plus or minus less than 1, plus or minus t less than 1. That is meaning that for positive time up to 1 and a negative time up to 1 the function value remains 1. So it is something like a rectangle signal whose width is 2. Now the question is what will be the Fourier transform of convolved signal y of t is equal to x of 2t and x of t by 2. So it is meaning that x of 2t meaning that a downscaling of the given signal, and the x of t by 2 meaning that upscaling of the given signal. So when we make the convolution between these two signals we have some result. For that result what is the Fourier transform they were asking. So here as we know the given signal is a rectangle signal, so that can be written as rect of t by tau. Now here the given problem it will be written as rect of t by 2. Tau value is 2. Again we know the Fourier transform of any rectangle signal is tau sinc of theta. So that can be expressed, this sinc function can be expressed as sine of this theta over theta. So this is standard form, rect of t by tau is equal to tau into sine theta divided by theta. In the same manner here the given function is rect of t by 2, that is equal to tau value is 2. So in this equation you replace tau is equal to 2. So 2 into replace the tau is equal to 2. So this is sine omega over denominator we have omega. So therefore the given signal having the Fourier transform of 2 into sine omega by omega. So to proceed further, we must recall the scaling property of Fourier transform. So x of t, whose Fourier transform is x of omega, if this signal is scaled by an amount of a, whose Fourier transform is 1 upon a, x of, for this omega, replace omega by a. So here, in the previous page, we referred rect of t by tau in the given signal having the Fourier transform of 2 into sine omega by omega. Now the first question is x of 2t, where a is equal to 2, whose Fourier transform is 1 over a value is 2. The given signal, the given transform we are writing, but there you replace omega as omega by a. So here omega as omega by a value is 2, omega by a. So this can be simplified like this, omega sine of omega by 2 over omega by 2. So let it be equation 1. Again, x of t by 2, there you take a is equal to 1 by 2. Again back to x of t by 2, a value is 1 by 2. So 1 by a value is 1 by 2. Again the given signal transformation is sine of 4 sine. 2 into sine omega by omega, 2 into sine omega by, replace omega as omega by a value is 1 by 2, so this can be simplified as like this. Let it be equation 2. Now the question asked is, what will be the Fourier transform of y of t, which is convolved between x of 2t and x of t by 2. Let me take a Fourier transform both sides. So y of t is y of omega. This is Fourier transform of x of 2t, and this is Fourier transform of x of t by 2. So we found as Fourier transform of x of 2t is equation 1, that is sine omega by 2 over omega by 2. And the Fourier transform of x of t by 2 is 4 into sine 2 omega over 2 omega. So when we simplify this, we have the answer as 4 into sine omega by 2 into sine 2 omega over omega. So among the given answers, so we get that is 4 sine omega by 2 sine 2 omega divided by 4. Okay, correct. Next question is Z transform of any sequence x of n is given as like this. So x of z is given like this. If y of n is denoted as the first difference of x of n, what will be y of z? So here y of n is the first difference of x of n. It is meaning that y of n is equal to x of n minus x of n minus 1. So it is meaning that it is a first difference. So before proceeding this, we will recall some property of a Z transform. So x of n, whose Z transform is x of z. If this x of n is delayed by amount of 1, whose Z transform is z power minus 1. It is delayed by 1, so that much power into original x of z. Suppose it is delayed by an amount of k, so z power minus k x of z. Again back. So this problem, y of n, when we take a z transform, y of z, this is x of z, x of n minus 1 z transform is z power minus 1 x of z, z power minus 1 x of z. In the given problem, x of z is given as like this. Just to substitute that, then z power minus 1 multiply inside. When we multiply inside, and then we proceed. So this is 7. When we proceed like this, this is plus 7. We proceed like this, we have the answer 2z plus 2, 8 by 2, 7 z square minus 3 z cube. So here the answer is A.